Before modern airports were built to handle giant aircraft, engineers were already creating flying machines that seemed to challenge the limits of aviation itself. At a time when computers still filled entire rooms, and many aircraft were smaller than today's private jets, designers were imagining something almost unbelievable: aircraft with wings wider than houses, aircraft heavy enough to weigh as much as a convoy of trucks, aircraft powerful enough to carry bombs, soldiers, vehicles, and equipment across oceans. But why would anyone build machines of this scale? The answer was not simple. It came from war. It came from the need for global transportation, and it came from a race between nations to control the skies. These aircraft were not built just to fly. They were built to solve problems that no ordinary airplane could handle. Some carried devastating weapons across continents. Some moved entire armies. Others transported massive components that would eventually help humanity reach space. Their engines were loud enough to shake the ground. Their wings were so large that standing beneath them felt like standing next to a building. And many of their engineering solutions were decades ahead of their time. Today we are looking at some of the largest and most impressive aircraft ever created, machines that pushed aviation beyond what many people thought was possible. And by the end of this journey, you will see an aircraft so enormous that it changed the meaning of heavy air transport forever. Boeing B-29 Superfortress. In the early 1940s, the world was locked in the largest conflict in human history. Military planners needed an aircraft that could fly farther, higher, and carry more than anything before it. The answer was the Boeing B-29 Superfortress. First introduced by the United States in 1942, the B-29 was not simply a larger bomber. It represented a completely new generation of aviation technology. At nearly 100 feet long, with a wingspan of more than 140 feet, it was enormous for its era. Fully loaded, it could weigh over 130,000 pounds. But size was only part of what made the aircraft revolutionary. The real breakthrough was what happened inside. The B-29 was powered by four Wright R-3350 radial engines. Each engine contained 18 cylinders and produced thousands of horsepower. Together, they generated enough power to push this giant aircraft to speeds approaching 360 miles per hour for a machine carrying massive fuel tanks, weapons, and a full crew. That performance was extraordinary. Unlike modern jet aircraft, the B-29 relied on propellers. Each engine used a reduction gear system to control the massive four-blade propellers, allowing the aircraft to produce enormous thrust without forcing the engines to spin at extreme speeds. But the B-29 was more than a powerful machine. It was designed around a new idea. The crew did not simply survive inside the aircraft. They worked inside a technological environment. The bomber featured pressurized crew compartments, a major advancement at the time. This allowed crews to operate at altitudes above 30,000 feet, where temperatures and oxygen levels made normal flight extremely difficult. It also introduced remotely controlled defensive gun turrets. Instead of placing gun positions directly in exposed areas of the aircraft, the system allowed crew members to operate weapons from protected positions inside the fuselage. Even the interior layout was unusual. A narrow tunnel connected different sections of the aircraft, allowing crew members to move above the bomb bays during flight. The aircraft's greatest advantage was range. Depending on mission requirements and payload, the B-29 could travel thousands of miles while operating at altitudes unreachable by many earlier bombers. That allowed it to strike distant targets and completely change the possibilities of strategic bombing. Today, preserved examples in museums show just how advanced the B-29 was. Looking at one up close, it is difficult to believe that this aircraft was designed more than 80 years ago. But if the B-29 proved that massive aircraft could dominate the skies, the next machine showed that size could become even more extreme. Messerschmitt Me-323 Gigant. During World War II, armies were no longer limited by roads and railways. The ability to move troops and equipment through the air became a critical advantage. Germany faced a major challenge. How do you transport heavy vehicles, artillery, and large amounts of supplies directly to distant battlefields? The answer was one of the strangest aircraft ever built: The Messerschmitt Me-323 Gigant, developed in Germany and entering service in 1942. The Me-323 was essentially a flying warehouse. Standing on the ground, it looked less like an airplane and more like a giant building with wings attached. It stretched roughly 90 feet in length. Its wingspan exceeded 180 feet, and its huge cargo body was designed to swallow equipment that normal aircraft could never carry. The aircraft could load vehicles, weapons, supplies, and hundreds of soldiers through its large front doors. Its power came from 6 Gnome Rochefane radial engines together. They produced thousands of horsepower. But despite having 6 engines, the Gigant was not designed for speed. Its mission was simple: carry enormous loads where other aircraft could not. Inside, the aircraft was almost entirely focused on cargo. There was little comfort, no unnecessary equipment. Every part of the design was created around one purpose: moving heavy materials. Depending on the mission, it could transport more than 100 fully equipped soldiers or tens of thousands of pounds of supplies. When all 6 engines started, the sound was unforgettable. A deep, uneven roar would spread across the airfield as the massive aircraft slowly built speed. But its enormous size created a major weakness. The Me-323 was slow, and once airborne, it became an easy target for enemy fighters. Without enough protection, many aircraft were lost during missions over contested areas. Despite its problems, the Gigant became historically important. It proved that aircraft could become airborne logistics platforms. The idea of using huge aircraft to move armies and equipment would continue long after World War II ended. And if 6 engines already seemed excessive, the next aircraft took a completely different approach. Instead of using runways, it used the ocean itself. Martin JRM Mars imagine an aircraft so large that it does not need a traditional runway. Instead, the water becomes its runway. That was the idea behind the Martin JRM Mars. Developed in the United States, the JRM Mars first flew in 1942 as a long-range military flying boat. It was designed for missions across the Pacific Ocean, where traditional airfields were limited. The aircraft was enormous. It stretched more than 100 feet long. Its wings extended nearly 200 feet from tip to tip. And with a maximum takeoff weight approaching 165,000 pounds, it looked less like an airplane and more like a ship that had learned how to fly. The secret was its massive hull. Unlike conventional aircraft, the Mars could land directly on lakes, bays, and coastal waters. This gave it the ability to operate in locations where normal aircraft could not. Power came from 4 massive Wright R-3350 radial engines together. They produced around 8,000 horsepower. Those engines turned enormous propellers, allowing the aircraft to carry heavy loads across vast distances. During World War II, the Mars was used to transport troops, equipment, and supplies across the Pacific. Its cargo capacity was impressive. It could carry tens of thousands of pounds of material or large numbers of personnel. But after the war, its story took an unexpected turn. Some examples were transformed into firefighting aircraft. The same giant hull that once carried military supplies was adapted to carry thousands of gallons of water. For decades, these aircraft helped fight large wildfires from above. The JRM Mars proved something important. An aircraft did not always need a runway. Sometimes, the entire ocean could become one. But even this giant flying boat was not the largest aircraft of its era. Because engineers were still trying to answer an even bigger question. How large could an aircraft become before it simply stopped looking like an airplane? And the next machine pushed that question closer to the limit than almost anything before it. Blohm and Voss BV-238 by 1944, Germany was already facing enormous pressure during World War II. Its resources were shrinking. Its air power was weakening. But even during this difficult period, engineers continued developing aircraft that pushed the boundaries of size and capability. One of the most ambitious examples was the Blohm and Voss BV-238. Designed as a long-range flying boat, the BV-238 was created for transport, patrol, and maritime missions. Before its engines even started, the aircraft looked almost impossible. It stretched more than 140 feet in length. Its wingspan approached 200 feet, and standing nearly 40 feet tall, it was one of the largest aircraft ever built at the time. Its maximum takeoff weight could reach around 220,000 pounds. For comparison, that was heavier than many modern passenger aircraft. The BV-238 was powered by 6 Daimler-Benz DB603 engines. Each engine was a powerful 12-cylinder design together. The 6 engines produced more than 10,000 horsepower. The aircraft did not rely on a conventional transmission. Instead, each engine used a reduction gear system connected directly to its propeller. This allowed the engines to produce enormous power while keeping the propellers operating efficiently. But the most impressive part was watching it move. Because the BV-238 was a flying boat, its runway was the water itself. During takeoff, the massive hull would accelerate across the surface. The 6 engines created a continuous roar. Water exploded around the aircraft as it slowly gained speed. Then, after a long struggle against its own enormous weight, the giant would finally rise into the air. Inside, the aircraft had space for large fuel reserves, equipment, and military supplies. It was designed to support operations across long distances, where traditional aircraft could not easily operate. However, the project came too late. Only one complete BV-238 was ever finished and flown. Before it could enter large-scale production, the war ended. The aircraft was eventually destroyed. But its importance was not measured by numbers. The BV-238 represented something much bigger. It showed that engineers were already imagining aircraft on a scale that would later define the future of heavy aviation. And when the war ended, the world entered a new competition, not for territory, but for technological dominance. The next giant would become one of the most recognizable aircraft in aviation history. Boeing B-52 Stratofortress. Some aircraft become famous because of a single mission. The Boeing B-52 became famous because it survived generations. When it entered service in 1952, nobody expected it to remain one of the world's most important military aircraft for more than 70 years. But that is exactly what happened. Built by Boeing in the United States, the B-52 Stratofortress was created during the early Cold War. Its mission was simple but enormous. Carry strategic weapons across continents, and remain airborne for extremely long distances. The aircraft was massive. It stretched nearly 160 feet long. Its wingspan reached about 185 feet, and its maximum takeoff weight exceeded 480,000 pounds from the ground. The B-52 had a unique appearance. Its long swept wings and narrow fuselage created a silhouette that could be recognized from miles away. But unlike earlier giants powered by piston engines, the B-52 entered the jet age. The B-52H version uses 8 Pratt & Whitney TF-33 jet engines. They are mounted beneath the wings in 4 separate pods together. They provide the thrust needed to move this enormous aircraft at speeds approaching 650 miles per hour. That combination was remarkable. A machine larger than many commercial aircraft could fly faster than many smaller airplanes. The B-52 was designed for missions lasting many hours. Its range exceeded 8,000 miles without refueling. With aerial refueling, it could remain operational far beyond that distance. Inside, however, the aircraft felt very different from its enormous exterior. The cabin was not a luxury environment. Crew members worked surrounded by instruments, controls, and navigation equipment. Every mission required intense coordination. The aircraft was originally designed for nuclear missions, but over the decades, its role expanded. It carried conventional weapons, performed reconnaissance missions, and became a symbol of military power. What makes the B-52 truly remarkable is not just its size. It is its ability to survive change. Over the years, engineers replaced its electronics, radar systems, and weapons, but the basic airframe remained. Some pilots flew aircraft that had already been flying before they were born. Few machines represent endurance and longevity like the B-52. But if 8 jet engines already seemed excessive, the next aircraft went even further. It combined 6 giant piston engines with 4 additional jet engines. a total of 10 engines, and it created one of the largest bombers ever built. Convair B-36 Peacemaker. When the Convair B-36 Peacemaker first took flight in 1946, it represented a completely new idea. The United States needed an aircraft capable of reaching targets across enormous distances. The solution was a bomber so large that it seemed almost too big to fly. The B-36 stretched more than 160 feet in length. Its wings extended nearly 230 feet, and its maximum takeoff weight exceeded 400,000 pounds. The wings were so massive that crew members could actually move through certain internal areas during flight. This was not just a wing, it was almost a structure within the aircraft itself. Power came from 6 Pratt & Whitney R-4360 radial engines. Each engine contained 28 cylinders together. They produced more than 20,000 horsepower, but the engineers were not finished. Latter versions added 4 jet engines beneath the wings. This created one of the strangest aircraft configurations ever built. 6 propeller engines, 4 jet engines, 10 engines working together on one aircraft. The B-36 could reach speeds over 400 miles per hour and fly thousands of miles without refueling. Its enormous size allowed it to carry huge bomb loads. Inside were massive bomb bays, pressurized crew areas, and tunnels connecting different sections of the aircraft. But flying the B-36 was not a comfortable experience. The crew dealt with intense noise, vibration, heat, and the challenges of operating inside a machine unlike anything before it. The aircraft was created during the early Cold War. Its primary role was strategic nuclear deterrence. Although it never dropped weapons in combat, its existence sent a powerful message. The ability to send such a massive aircraft across continents changed military planning forever. The B-36 proved that aircraft were no longer limited by the size of traditional designs. If engineers could build something this large, the only remaining question was, what else could aviation carry? The answer would come from a completely different type of aircraft. Not a bomber, not a weapon, but a flying warehouse created to carry the impossible. That machine sewing to transport the future of space exploration, and it looked unlike anything that had ever flown before. Acro Spaceline's Super Guppy. Some aircraft are built to carry weapons. Some are built to carry soldiers. But the next giant was created for a completely different purpose, carrying pieces of the future. During the 1960s, the United States was entering the space race. Rocket stages, spacecraft components, and massive aerospace structures were becoming larger and more complex. But engineers faced a simple problem. These parts were too large to transport by road, they were too fragile to move easily by ship, and they were too big to fit inside any normal aircraft. The solution was one of the strangest looking airplanes ever created. The Super, built in the United States and introduced in 1965, the aircraft looked almost like a normal airplane that had been stretched beyond imagination. Its fuselage was enormous. The cargo section was more than 20 feet wide. Inside, it looked less like an aircraft cabin and more like a flying industrial warehouse. The design was unusual because the aircraft was not built for speed. It was built around one question: how do you move something that is too large for every other form of transportation? The Super Guppy used 4 Allison turboprop engines together. They produced thousands of horsepower and allowed the aircraft to reach speeds close to 300 miles per hour. But the most impressive feature was not the engines. It was the nose. The entire front section of the aircraft could open. Instead of loading cargo through a small side door, engineers could swing the nose open and place massive components directly inside. Before loading, cables and systems had to be carefully disconnected. Then the giant nose would open, revealing a cargo space unlike anything else in aviation. The Super Guppy became an essential tool for the American space program. It transported rocket components and large aerospace structures that helped support missions during one of the most ambitious periods in human history. IT also later helped transport aircraft components for companies such as Airbus. The aircraft looked unusual. Some people even called it strange. But its design solved a problem that no conventional aircraft could handle. It proved that sometimes the best solution is not building a smaller machine. It is building something completely different. But the next aircraft was not designed to carry delicate space hardware. IT was designed to move almost anything: vehicles, equipment, supplies, even entire sections of other machines. Antonov An-124 in 1965. The Soviet Union introduced an aircraft that looked like it had been built for one purpose: moving everything that stood in its way. Developed by the Antonov Design Bureau, the An-124 Anti became the largest turboprop aircraft ever produced. Its mission was heavy transport. The aircraft needed to carry military vehicles, oversized equipment, troops, and supplies to locations where normal cargo aircraft could not operate. The numbers were impressive. The An-124 stretched about 190 feet long. Its wingspan reached more than 200 feet, and its maximum takeoff weight approached 550,000 pounds. But the most unforgettable part was its power system. The aircraft used 4 Kuznetsov NK-12 engines. Each engine produced around 15,000 horsepower. These engines powered enormous counter-rotating propellers. Instead of one propeller turning in one direction, 2 sets of blades rotated opposite each other. This improved efficiency and created one of the most recognizable sounds in aviation. When the An-124 approached an airport, people could hear it before they saw it. The deep mechanical roar of its massive propellers made it sound unlike any other aircraft. The aircraft was designed to operate from rough and undeveloped airfields. Its landing gear spread the enormous weight across multiple wheels, allowing it to land in locations where many heavy aircraft could never operate. Inside, the cargo area was enormous. It could carry trucks, armored vehicles, helicopter components, and huge quantities of supplies. A rear loading ramp allowed equipment to drive directly into the aircraft. This turned the An-124 into a true airborne bridge. It connected remote locations with heavy equipment that previously required complicated transportation networks. The aircraft served in military operations, humanitarian missions, and industrial transport. It proved that enormous size could still be practical. But aviation was moving toward a new era. Propellers were slowly being replaced by massive jet engines, and the next aircraft would become one of the largest jet-powered cargo planes ever created. Lockheed C-5 Galaxy. Few aircraft can make a military tank look small. The Lockheed C-5 Galaxy was designed to do exactly that. First flown in 1968, the C-5 became one of the largest military transport aircraft ever built by the United States. Its mission was simple: move massive equipment anywhere in the world. The aircraft was enormous. It stretched around 250 feet in length. Its wingspan approached 300 feet, and its maximum takeoff weight exceeded 800,000 pounds. Standing next to a C-5, many vehicles appear surprisingly small. The aircraft was essentially a flying warehouse. Its cargo compartment was longer than many buildings. Inside, it could carry helicopters, armored vehicles, trucks, and other oversized military equipment. The aircraft used 4 powerful jet engines. Each engine produced more than 50,000 pounds of thrust. Together, they allowed this massive aircraft to reach speeds above 500 miles per hour. But the most impressive feature was how it loaded cargo. The C-5 could open from both ends. The front section of the fuselage could lift upward, creating a giant entrance. Vehicles could drive directly inside. Then, after unloading, they could exit through the rear. This design dramatically reduced loading time. The aircraft also used a complex landing gear system with dozens of wheels. The goal was simple: spread the enormous weight across the runway. The C-5 became a critical part of military logistics. It transported equipment across continents, supported humanitarian missions, and moved cargo that would have taken weeks by traditional methods. Even after decades of service, the Galaxy remains one of the greatest examples of heavy air transport engineering. But there was still one final giant An aircraft that pushed size and carrying capacity even further. A machine so large that it looked less like an airplane and more like a warehouse with wings. Antonov An-124 Ruslan. In the early 1980s, the Soviet Union faced a difficult challenge. Some cargo was simply too large for existing transport aircraft. Industrial equipment, Power plant components, massive vehicles, objects that could not fit inside ordinary cargo planes. The solution came from the Antonov Design Bureau, the An-124 Ruslan. When it first flew in 1982, it immediately became one of the largest aircraft ever built. The numbers were extraordinary. It stretched more than 220 feet long. Its wingspan reached around 240 feet, and its maximum takeoff weight approached 900,000 pounds. The cargo compartment alone was enormous. It could carry more than 300,000 pounds of equipment. Inside, it looked less like an airplane, and more like a giant industrial warehouse floating through the sky. Power came from 4 Progress D-18T jet engines. Each produced more than 50,000 pounds of thrust. Together, they gave the aircraft the ability to transport massive loads across continents. The An-124 was designed with flexibility in mind. It could operate from less developed airfields. Its landing gear used 24 wheels to distribute its enormous weight, and loading cargo was made easier through a unique design. The nose of the aircraft could lift upward. The front landing gear could lower the aircraft closer to the ground. This allowed heavy vehicles and equipment to move inside more easily. Inside, the cargo hold built-in cranes helped move extremely heavy objects without requiring large ground equipment. During its career, the An-124 transported everything from helicopters and generators to industrial machines and unusual oversized cargo. It became one of the clearest examples of a simple idea. Sometimes, the only solution to a transportation problem is to build something bigger. The legacy of aviation giants throughout this journey. We saw aircraft that seemed impossible. Bombers with enormous wings, flying boats that turned oceans into runways. Transport aircraft capable of carrying entire vehicles, machines built for war, science, and global logistics. Each one represented a different moment in human ambition. The B-29 showed that long-range aviation could transform warfare. The Mi-323 proved that aircraft could become airborne logistics platforms. The B-52 demonstrated that a machine could survive generations of technological change. The Super Guppy showed that even the largest aerospace components could be moved through the sky. And aircraft like the C-5 Galaxy and An-124 Ruslan proved that the sky could become a highway for the heaviest objects on Earth. These aircraft were never just machines. They were engineering experiments pushed into reality. They represented a simple human idea. If something seems impossible to move, build a machine capable of moving it. Today, many of these giants exist only in museums. Others continue operating around the world, but all of them changed aviation forever, because every generation of aircraft begins with someone asking the same question: how far can we go? How much can we carry? And how large can we build before the sky says no? If you enjoyed this journey through the largest aircraft ever created, subscribe and join us for more stories about the machines that changed our world. Because behind every incredible machine is a story of human imagination, engineering, and the endless desire to push beyond limits.